This is the second part of the graphing polynomials worksheet. So we're going to start with problem number 5 here. We've got a list of characteristics that we're given, and we're going to try and see if we can take those characteristics and turn it into a graph. So first characteristics, we have x-intercepts at -2. So I'm going to go ahead and mark these. I may or may not be able to draw the graph, but at least I can mark out what I'm given. So x-intercept at -2, +2, and at 5. Okay, so I've got my x-intercepts marked. Negative a value. Okay, we'll have to look at more at that. And degree 2. All right, we're done. So, fundamental theorem of algebra says a second degree function can only have 2 zeros. And that means this graph that crosses the x-axis 3 times has at least 3 zeros. This is not going to work for us. All right. So, explain if the graph cannot be sketched. A second degree function cannot have 3 x-intercepts. And that's why the graph cannot be sketched. So yes, I marked the x-intercepts, but no matter what way I try and draw it, I'm going to create something other than a second degree function, so that's not going to work. All right, so problem number 5, no graph. All right, number 6, let's see what we've got here. Okay, fourth degree function, so something maybe in a U-shaped graph here. Absolute minimum at x equals -2. 2 real roots. Okay, now this might seem a little bit weird, but it's okay to have a fourth degree function with 2 real roots because that means the other roots are imaginary. And that does not mean that they're fake. Imaginary numbers are things that exist. You just can't graph them on the real number lines. So let's see what we've got for end behavior here. All right, end behavior as x is going to infinity, f of x is going to infinity. So over here as x goes to positive infinity, my function needs to be heading towards positive infinity. As x goes to negative infinity, f of x has to go to positive infinity. All right, so that's going to be okay because this will work. These two match, which means it works for an even degree function. Absolute minimum at x equals -2. So at -2, I'm going to say that the lowest my graph gets to is that point right there. Now you can pick the lowest value, and all that happens is your graph just can't go any lower than that. All right, that's what the absolute minimum means. 2 real roots means you're going to go through, and I'm going to mark it here, 2 x-intercepts, and that's okay. All right. So you could have a graph that does something like, all right, we're going to hit that minimum here, and then maybe do something like this. All right. So we've got degree 4. Yeah, that could be a degree 4 function. Absolute minimum right here at x equals -2. 2 real roots, and the end behavior works. All right, so yes, that graph can be created. All right, problem number 7, which is the last one. Let's see what we got here. A negative a value. All right, so that means if this is, well, I'll just look next. Okay, even degree function means that you're going to have some kind of graph that looks like that. All right, some kind of concave down graph. Absolute minimum at, well, wait a minute. You can't have an absolute minimum if your graph is concave down. All right, that's not going to make any sense. So let's see if I can explain this well. An even degree function with a negative a value, all right, these two have to go together here, all right, cannot have an absolute minimum. All right. So what's going to happen here is if you have an even degree function, it's that U-shaped graph, kind of that parabola looking thing, right? But if it has a negative a value, it's got to be concave down. It's reflected over the x-axis, which means you could have a maximum, like an absolute maximum, but you cannot have an absolute minimum. That's just not possible. Now, even if you ignore this absolute minimum part and you go down to your end behavior, so this one says as x approaches infinity, f of x approaches positive infinity as well. Well, that doesn't make any sense for our graph because this graph is dropping down to negative infinity because it's been reflected. So you could either talk to me about the absolute minimum as being a problem, or you could tell me the end behavior doesn't work. In either way, it won't make this graph happen. So either method, you can tell me either. You don't have to tell me both, but using either of them, that graph for number 7 doesn't exist. All right, so that's the last possible problem on this particular page. As always,